question number 4.
An aircraft is flying from Oxford to Cambridge. Planned track is 074 degrees magnetic.
Right, so it's flying a planned track of 0474 degrees magnetic, distance is 70 nautical miles, heading is 65 degrees magnetic. Having flown 30 nautical miles, the pilot pinpoints the aircraft position overhead Cranfield, 4 nautical miles left of planned track. If you go through question number 4 and 5, and if you can do that, that's it. You have kind of mastered 160 to the point where navigation is concerned, because it is kind of dwelling around everything that is possibly there in the concept. Right, so here you're traveling from 2 different points, point A to point B, Oxford to Cambridge. Your planned track is 74 degrees magnetic. So your course, or as the planned track, it's called 74 degrees magnetic. Therefore, from the true direction reference, it's more like this, which is from Oxford. I'll put O here, and Cambridge I'll put CM, because we have the Cranfield coming up. Right, what is this track? This track is 74 degrees magnetic, and
distance is 70 nautical miles.
Distance is 70 nautical miles. That's right. Right. What heading are you flying? You're flying on a planned heading of 65 degrees. Right?
70 nautical miles. So from here I am following a heading of 065 magnetic. Heading of 065 degrees magnetic. Okay.
So yeah, that's it. Aircraft is flying from Oxford to Cambridge. Planned track is given, distance is given. You're flying a heading of 65 right from the beginning.
Yeah.
65 degrees, right? Now, having flown 30 nautical miles, so 30 nautical miles, you have already flown, which means it is taken from O, right? So it's 30 nautical miles here. So take for example 30 nautical miles, and if I kind of draw an arc here, that's a 30 nautical arc. What happens after 30 nautical miles? What did you find?
I find that the pilot pinpoints the aircraft position overhead Cranfield, that is a place, CN, that 4 nautical miles left of the planned track.
That's right. So you can see a track is going from O to C, that's 074. Therefore, left side is over here, or north of it, and therefore a perpendicular line is going to take you all the way here. What is the distance of?
Distance of is 4 nautical miles.
4 nautical miles. Alright, so let me put this up here. This is the track made good. So with 65 degrees, you expect to fly a track of 74. Unfortunately, you drifted to the left here, and you ended up 4 nautical miles over and a pinpoint, and you realize that you are 4 nautical miles left of the required track.
This is 40 nautical miles now.
Right.
Okay, yeah.
You have to find what is the track error overhead Cranfield.
Cranfield, yeah. So it is easy.
So this point is Cranfield, let's see N there, Cranfield. And how do you find track error? Very, very basic question, right? You can find track error, angle between planned track and track made good. Yes. How will you do that? Applying 160.
Yeah. So it's like 8 degrees.
That's right. Distance off by distance gone into 60.
Gone into 60.
That is.
So distance off is by 4 nautical miles.
That's right. Distance gone.
Distance
gone is 30. Remember, this is the actual distance gone by me, but I can take it as equal to 30 because it's the angle is very less. Yes, correct. So that is 30 nautical miles.
To 60.
And we can see, you don't have to probably do this because over 30 nautical miles, 4 nautical miles is actually going to be me 8 degrees of track error. No, track error to what?
Towards the left.
Towards the left. It's planned track to the track made good, towards the left. Alright, perfect. So first question is answered. What is the track error overhead Cranfield? That is 8 degrees to the left. Question number 2. What is the track made good from Oxford?
Okay, so it is my planned track was 074 degrees magnetic.
That's right.
Since I have flown 8 degrees to the left, so 74 minus 8 degrees.
That's planned track minus your track error, left track error. So planned track is 74 minus 8.
Yeah. It will give me 66 degrees magnetic.
66 degrees magnetic is your track made good.
Yeah.
Right? So that's it. Well answered. Again, what's the next one? What was the expected drift? Expected drift is your planned drift.
Okay.
right?
Okay, so I was expecting that I'll be flying at 065 heading and my planned track will be 074.
That's right. So it is the angle between heading and
Yeah, heading and the planned track.
planned track measured from the heading, right?
Yeah.
So you have, you see here, there's since I placed the aircraft right in the beginning, the problem that occurred here is since my track made go to 65, see what happens, the heading gets 65. So I'm supposed to place the aircraft further here. But since I placed the aircraft right in the beginning, I didn't know that. Right? So I'm just kind of redrawing this, repositioning this aircraft a bit. Do you understand what I'm doing here?
Yeah.
Right? So because the aircraft has to be oriented like this.
Like just the one I have drawn.
Exactly, yes. Very good. So this is 60, how much is the heading? 65 degrees.
It is 065 degrees.
Right? So measured from the heading, you're asked to find the planned drift. So what is that? From the heading towards the planned track, and this whole angle here.
Yeah. So it is 9 degrees towards right.
That's right, 9 degrees. That track is towards the right of heading. If I don't do anything about it, then I'm going to drift towards starboard. So it's 9 degrees.
It's starboard.
Starboard. That's right. So it's always advised to place the heading a bit later. First, as I told you, settle it down with the tracks, and then we can place the aircraft's heading. Yes. So that is 9 degrees starboard. What is the actual drift beam?
Okay. So I have flown an track of 066 degrees.
That's right.
And my heading was the same 0651.
That's right. I didn't know that I drifted off. I'm just flying a plan heading. So actual drift is the angle between?
Actual drift is the angle between heading and the actual track.
That's right. Track
measured from heading.
That's right.
So from heading is 065 and TMG is 066, so it is 1 degree starboard.
Exactly. So it's going to be 1 degrees, and since track is to starboard of heading, 1 degree starboard. Right? So alright. Echo. Yep. What alteration of heading should be made over Cranfield to fly direct to Cambridge? Very similar to the previous question, right? So, as I told you, when they ask you about heading, keep heading aside, peace, set the track first, because otherwise you won't be able to, because track change has to be understood to know the heading change, right? So, when they ask you to find out heading alteration, what are you trying to find out? You're trying to find out track alteration, and that's exactly going to be equal to heading alteration, right? So what is the track that you intend to fly now from sea? That's going to be this track here all the way towards Cambridge, overhead. What track are you flying at the moment? If I don't do anything about it, I'm going to drift off all the way. That is 66 degrees, right? So two different methods, two different processes here. One, I'll turn right to stop drift.
And then the closing angle to reach crank.
Exactly. Now I turn over closing angle to track overhead Cambridge, right? So the first track is how much? That is very similar. You can see these two parallel tracks.
Yeah.
Transversal.
8 degrees.
8 degrees. That's right. Now it is towards the right. Yes. What about this one? This is same as the closing angle.
Closing angle. Yeah.
Over here. And how will you find out? That's again by applying 160.
160. So it is distance off by, that is 4 nautical miles,
Yeah.
divided by distance gone, that is 40 nautical miles, multiplied by 60.
That's right. Distance off is again 4 nautical miles. Distance to go is the total distance is 70. Therefore, this distance is 70 minus 30, which is 40 into 60. Therefore, that is going to be 6 degrees, right? And as far as the track change is concerned, you have to change by 6 degrees to the right.
Yeah.
Right? Therefore,
the total change should be 8 degrees plus 6 degrees.
That's right.
That is 14 degrees towards right.
The total track change is equal to total heading change. And that is equal to 8 plus 6, 14 degrees to the
right.
Right, there's an increase in heading, right? Now, at one point of time, you necessarily don't have now split up into two different sections. You can just find it out straight, that's fine. But this is the component of that particular 14 degrees. It has both these components. One stopping the drift and other closing you towards your destination or towards interception, whichever is there. Now 14 degrees right. So what is the answer? What is the heading alteration?
So I was flying a heading of 065.
Read the
Then
question
I
again.
realized, so I'll have to change my heading increase my heading. So it
Yeah.
is 065 plus 14 degrees. So I'll have to fly a heading of 079 degrees.
You're answering question number F. E. So read the question again then. If it is E.
What is the alteration of heading should be made? Okay, alteration of heading, that is the 14 degrees right.
That's right. It's the same thing. 14 degrees. 14 degrees right. Yes. Now what we're just explaining is they're asking what is the new heading to be flown from overhead crank field. So since we have the heading change alteration here, what is your initial heading?
It was 065 degrees.
So initial heading is 065 degrees. Yes.
Right.
Now what do you apply here? You apply a track change which is equal to heading change,
Degrees right.
which is 14 degrees to right. Right is clockwise, which means you basically have to add. So that is new heading to fly direct.
Yeah. It is
65 plus 40.
40. 79 degrees magnetic.
079 degrees magnetic is the new heading to be flown. So if I place the aircraft here, you can see what is this track. This track is 66 degrees and 14 degrees right will take me to a track of 80 degrees.
Yeah.
Magnetic is the track required, and to fly the track, so see what was the actual drift. The actual drift was 1 degree starboard. So with 1 degree starboard, if I want a track of 80 degrees, the track is starboard of heading by 1 degree. Therefore, my heading has to be
1 degrees.
to the left. Just 79 degrees magnetic.
So the last thing, please repeat it.
Yeah, so what I just told you was that the track which you are required to fly from Crankfield to Cambridge is 80 degrees is the track. I hope you understood because it is 66 and this is the track made good is 66. 14 degree right track change, therefore it is 80 degrees magnetic is the track required to fly towards destination. Right, I'll start from the beginning again. What is the track made good? 66 degrees.
This is, yeah, 66.
Degrees.
Okay, yes.
Right? Plus 14 is going to give you 80 degrees magnetic.
80.
Now, what is the actual drift experienced? Actual drift?
Yeah, that is 1 degree starboard.
So with actual drift of 1 degree starboard and the required track of 80 degree magnetic, what should be your heading? 79. You can find it that way, or you can even think about it that track change is equal to heading change. Track change is 14, your initial heading is 65, and therefore your final heading is 79. So you can think of different ways. You can't say one of these or the other, it's just two ways of looking at the question. Right? Happy?
Yeah.
Alright.